Hello everyone, welcome back to another C++ video. Today I got for you a bowling program me and my friend came up with and I kind of expanded on. So first off, we're going to have an array here that will hold basically the two bowls for each of the frames. So, in bowling, when you bowl, you get 2 tries or whatever per frame. You get 2 bowls, 2 tries. I'm not sure what the proper term is, but basically that. And then we're going to only do up to 10 frames. I know there's can technically be 12, but we're not going to consider that for right now. We're just doing 10 simple frames. So basically our array has this 10 by 2 um, size, I guess. So it has a 2D array by 10 by 2. Also in this program, we're going to create a struct named bowling, and inside of bowling, its members are going to hold, or we're going to have members that are going to hold the frame number, the pins for the first bowl, the pins for the second bowl of the frame, and then later on we're going to add a enumerator type as well. We're also going to be creating a vector that will hold pointers. And remember what pointers are. Pointers hold address values, right? So they hold an address. So this vector will hold pointers, and these pointers will point to the bowling type. So our struct type is bowling, so we will have pointers that will point to our struct type, basically. Then with using this vector, we will basically use our struct and fill our information and do some other funky stuff with the vector as well. So since we are using our vector pointers, we will have to dynamically allocate our structs, and we'll get into how to do that. So let's just kind of jump into it. So I've got some global constants here. We've got basically the frame and bowl. So the whole size here of the array, we have a 10 by 2. And I've created this array here that with some pre-filled information. And I know this is a little bit of funky syntax, but basically this is where the array initialization starts, and that's where it ends down here. And I just separate it by each of the frames. So we have 10 here, each with 2 values, the first value being the first bowl, the second value being the second bowl of the frame. So we have 10 frames there, and each of those are the value of the scores of up to a strike or, no pins or gutter or whatever. And I also have created a structure. So to declare a struct, you obviously use this keyword struct here and then name your type. So I've named this type bowling. So this is going to be our type of, well, it's basically our type, and this is going to be the type we're going to be using throughout our program to reference to the struct. So again, just as a reminder, just like how we declare variables, like so back up here, let's say we have a variable of an unsigned int or unsigned short int, that's a data type. So what we're doing here is creating our own data type called bowling. So we will be using that instead. Um, and so inside of our structure here, we have basically 3 variables here so far, one called frame, one called pins1, and one called pins2. And this basically, the frame will hold the frame number, the pins1 will contain the pins knocked over and pin for the first one, the first bowl, and then pins2 for the second bowl, the second throw. And all these guys are just going to be the type of unsigned short int, so they will hold positive integer values. And the short just means it'll take up a little bit less memory because these are not going to be huge numbers. And later on we'll get to that. And so I've also created main. So first thing we're going to do to start with this is create a vector. So again, to create a vector, that's part of the standard library. So we have to use std unless you're using namespace. And then we have a vector, declare it like that. And then we're going to use these brackets. Now this is the type of the vector. So this is going to be what the vector is holding. And so we want this vector to basically hold pointers to our structure type. So to be able to do that, if we type our structure type here, bowling, and we put the asterisk there again, that means we have a vector here of type that is pointing to our bowling struct. So what this means is we're going to, this vector is pointers, and again with pointers we're dealing with addresses. So this vector will actually contain the addresses of our structs. So our structs will be somewhere in memory, and our vector will contain the address for each of those structs, and we will access our structures and fill our information through the structures and the vector. So let's go ahead and name this guy here something like this. And now we've declared our vector here. So we have this vector here called bool struct pointer. This is going to be used to reference our vector. And remember, vectors are they hold multiple values similar to arrays. This is just a 1D vector, so they only hold one thing. And what they hold is they hold basically it's a pointer, so it's going to hold addresses that point to the type of bowling. So that remember, they point to the type of bowling which we're going to create. So let's get to using this stuff. Alright, I've gone ahead and added a function prototype here because we're going to start using a function here called getFrame. So I've created this void function. We're not returning anything, so it's void. Function name getFrame. And what we're going to be passing through is we're going to be passing in a type of vector, with this vector type being a bowling, pointers to the bowling type. And then we're going to pass it by the ampersand, pass it by reference. So we're going to be basically declaring this vector from in main here and passing it through, and we're going to be passing it by reference, meaning we're changing this vector here inside of main so that we can use it along later. And here I have my function definition here. Again, we're returning nothing, so void. And again, I'm taking this argument parameter here of a vector with the type pointing to bowling, and we're passing my reference again, and I've named my variable here for this function bool struct pointer again. And so here we go. I've started out with just a simple framework here. So since we are using a vector, vectors are very similar to arrays. So for inside of getFrame, what we're going to start to do is fill our data. So I've filled out a for loop here, because what we're going to be doing here is taking our data here from this const array. So I've just declared this up here. This is just basically to see information organized in some kind of manner. I would use a file, but I think it's easier to see just how to just see it through here with an array. So what we're going to be doing is looping through the number of frames here, which is going to be 10. We're going to loop through each of the frames here so we can grab our data. Right, so we're going to start at frame, frame is going to be 0, but we're going to start at that first frame there, which is this one, frame 1, which will, our two bowling numbers are going to be bowl element 0. The first bowl here will be 10, and the second bowl will be 0. So we'll go through that. So we just got I starting at here 0, right? So, and a data variable here starting at 0. This will be used here to see if we're at the first bowl of the frame, or the second bowl of the frame, basically. So there's a couple ways to get started with this, but just to clarify again, we're just going to be going through this array and grabbing this information. So there's a couple ways. So what we want to be able to do to our vector is use the pushback function. So pushback is a function of the vector basically type that allows us to add something to the end of the vector. So the thing we want to be adding onto the end of the vector, right, is our type here, right? So our type is pointers to bowling. So for having a pointer, again, we need an address. So if we're going to push something back to our vector, we have to push back some kind of address. And not only any address, but an address of the bowling type. So there's a couple ways to do this. So I'm just going to get started with one. But here we go. Let's start by declaring a temporary type of bowling pointer. So we've created a variable temp_ptr here that points to a bowling type. So we see here our types match up, right? We both have a thing that is pointing to the type of bowling. And what we're going to do here is need the address. What we could do is set it to null pointer first. Remember, this just sets it to default, or not to, kind of like a default state, like a 0 or null, so that you can just declare it and then initialize it or assign it later on. But we're going to assign it right now. And what we're going to do is dynamically allocate. So we're going to use the new variable to dynamically allocate. And we're going to dynamically allocate our bowling type here. So we do new bowling. And so what this is going to do is this new keyword is used to dynamically allocate. So thus, when we dynamically allocate, it's going to return the address to our temp_v ptr here. So don't mind me. Alright, so this temp_v ptr, geez, I can't even say that, is going to hold an address of this new dynamically allocated struct here. So somewhere in memory, there's a little chunk of saved memory that can hold our bowling struct here, that can hold all of the stuff for our bowling struct. And so now we've created that in there. And now what we can actually do is, well, if we can access this, start trying to access this guy. So since we're using pointers, we are going to have to use a different operator to access inside of our struct. So since we're using pointers, we have to use the little pointing guy. And as you see, these guys come up, and we want to access pins 1 and pins 2, and the frame as well. So if we access the frame, well, we can actually set this guy to kind of our I value, right? So this will be kind of our frame number. But remember, since we're starting at 0, we gotta add 1 to our I so that it correlates. And this, so since we're starting at 0, we'll start at frame 1, and then we'll assign frame 1. And so now we have our thing. We can also just continue to assign to the next variable here of pins 1. So let's just set this guy, and so now we're going to access our data here, because our data is going to give us our bowling, the pins knocked down for frame 1. So we have our array here called bowling frame data, and again, to access the array, we have to use the kind of the row by column thing. So our I is going to be our row, which correlates to our frame. So we're going to start with frame 1, right? So the frame 1 has those 2 values, and those 2 values are going to be determined by data here. So data will start at 0. So if data is 0, it's going to be this first value. If data is 1, it's going to be a second value. So it's only going to alternate between 0 and 1, go down as it frames. It can only be the data can only be 2 values here, 0 and 1. And so now we've occupied some stuff, but I'm going to show you one other way you can do something. So let's go ahead and actually just try pushing this guy back right now. So we have our address inside of our temp_v ptr here. So if we go ahead and push that guy back, so remember, this guy's our address, right? We've dynamically allocated, so it returns an address here. We've used our temp value to manipulate some values already, but I'm going to show you something else. So now we're pushing back. So it'll push back with these values, and the other values in our struct, like pins 2, is going to remain the default 0 or garbage, not set data, basically. These will still be set, and it'll pass that through and add that onto the end of the vector. So now if we want to, let's say, use our vector to change the data, we can do that as well. But first, what we're gonna have to do is we're gonna have to use the vector like an array. So we're gonna have to know which position, which element it's at to try and access the correct information we want, right? Since we're correlating it to each frame, we want to grab the right frame basically. So to do that, since we just pushed it back, well, it's going to be added onto the end. So if we just grab the size, we can actually grab the size here, and the size returns the size of the vector. So if we push back 1, it's going to return 1. So size is a function of our vector here, just like pushback. Pushback is a function of our vector. And then we're going to minus 1 because our size is going to be the total size, but we need to minus 1 since we start at 0. Now let's go ahead and just increment our data here. So now we can go on to our bool number 2 to try and insert into our pins2 variable. So now that we have the element for our vector here, let's go ahead and try and access. So we're going to access at our temp int here, which should be the our latest or last element in the array or in the vector, the one we just pushed back. Therefore, we can point, and we should be able to point to this other variable here, pins2. So again, with our vector here, we've accessed our certain element, and just like this kind of we think of as one whole unit, right? So at element, basically the last element, we're accessing that. That is the address, and so now we can use our address to point to our pins2 like we did here. So remember, we use our new to dynamically allocate and return an address to temp v pointer, and then temp v pointer will point to our frame and point to our pins to change them. So we think of these guys kind of as one value of frame and kind of one value is pins1 for this temp v pointer. And so same thing here, right? So if we have our vector of multiple things, we just have to access one of those elements of the vector to be able to do similar things. So we access the element just like an array to use it just like an array here. So if we want to access the data here, right, we use an array, we use the brackets, etc. And we do that. And now we're accessing our pins2 through our vector. So we're going to go ahead and set this to our bowling frame data of the same frame, but of the next bowling data, right? So now our data should be at 2, and notice we should have, our data should be at 1, so now we're accessing the second element, which should be that second number of 0. There's another thing we can do here is with our vector, there is another function called .at. And what .at is another function of a vector that basically returns that same element, so the position at that element. So if we have temp int as basically the last position in the vector, we can also, instead of doing it this way, you can use .at, and we should be able to do the same thing and manipulate it in the same way. But I'm not going to do that. So there's a couple ways to do a bunch of this stuff. Now, if you want to get real fancy, there is even another way to do this, strictly with pushing back. So just for the sake of the example, I reset this to 0. So we're pretending we're kind of still at the same frame here, and we've reset to that first bowl. So if we're back at this 10, and what I do is I just take my vector and I just use my function pushback. And what I actually do is just push back and create and dynamically allocate my bowling type in here. So I use the new keyword just directly in my pushback here. And what I do is I use these brackets to initialize this struct. So we're dynamically allocating the struct here, and I initialize it to these variables. So our first one is frame. So that's going to be 1 through 10. So that's going to be our I. That should actually be our I plus 1 value. So our I plus 1 value. And then basically our pins 1 should be is next. So our pins 1 should relate to our frame, right? That same frame number with the first element of data being the first bowl, the first try of that frame. And then the second one, right, for pins 2. So plus plus data will increment before and we'll go to the next one. And that is another way to do that. So as you can see, there's multiple ways to do these things, but in the end, they all kind of get the job done. But, you know, you can explore on your own and mess with this. Let's just recap this get frame here. So what we're doing is literally filling our data. So we've passed our vector. So our vector is being referenced in this function as bool struct pointer. And we're looping through each of the frames of our array. Right, so our frames are 10, so we're looping through 10 frames, and we're going to use this data. And we use it in a couple ways to assign it to basically our struct that we want to use. So we're taking it from the array and putting it into our struct through this whole thing, and by adding it to the end of a vector. So go back and recap if you think you're still unsure about this. Hopefully I explained it well enough, but if not, you know, make sure to leave a comment or something, and maybe I can go focus more in depth on that. So now let's move on to the next step here. So I've gone ahead and added in some stuff. So basically what I added in here is I've created an enumerator. And there's a couple things you can do with enumerators. So first off, I'm just going to say that I'm just going to go over declaring a strongly typed enumerator, which is a little more safe and basically cannot act as an integer value if I don't want it to be an integer value. So to be able to declare it as a strongly typed enum, instead of just typing enum here, right, instead of a regular enum, you go ahead and type enum class, and that makes it a little bit safer, and you'll see how we'll use that later on. So to go over enums real quick, enums is basically, I like to think of it as a state, kind of. So a quick example is if we're thinking about, let's say, the days, we can create an enum called day, and we can assign it Monday, Tuesday, Wednesday, Thursday, and basically we can use that enum to assign a day, like today is Monday, and then change it when the day becomes Tuesday, etc. So what we have here is a enum, a strongly typed enum called declared enum class called pin status here, where we've got a couple things here. So we've got a state where maybe we've earned a strike in this bowling game, or we've got the status of we've earned at least a spare, right? We've hit at least all 10 pins, or maybe we've hit the double gutter, we've got absolutely 0 pins between frames, or the state of none, which means just, you know, you've got, you know, nothing special, you just hit pins or whatever. So we can use these states to basically set it to one of these states and do some cool things with that. And so what I've gone ahead and done is in my bowling struct here is also added this type of pin status. So we have this enum called pin status, so we're adding this type here of it called pin st. And so pin st will allow us to set our state to these 4 possible states of our bowling scenarios. Either get a strike, spare, gutters, or none. I've also created another function here, again returning nothing, so a void function here, taking that same vector we're going to pass through. And so I go ahead and call my function down here in main again and pass the same vector by reference, so we're going to be accessing the same vector here up here in main. There's my get frame function, so here is my get status function. So void get status, taking in that same thing, and I've renamed our variable here for this function the same thing by bowl struct pointer, so that's what we're going to be using. So I have this outline here, so since we have successfully looped through the vector, we've added everything to our vector. Now let's see which ones are maybe strikes, or which ones are spares or gutter balls, and let's see how we can do that and check to well, let's just see how to do that. So I've just created this bool variable called strike here for when we find a strike, because in the end we're going to check to see if we have got a strike in this bowling game. So what we're going to go ahead and do is start with looping through our vector, right? So our information is stored in all of these structures, which is being pointed to by this list of pointers in our vector. So we've kind of got a couple steps to go through, a little couple layers deep, and it might get a little confusing, but we'll hang in there. We'll get through it. So I want to loop through this vector. So what I'm going to do is use a for loop, because I can get the size of the vector, because we can do that with our lovely vector here. So I create another variable here, just assign it to 0. Let's get our vector here, and let's find out the size of our vector here, and loop up until then. So loop from element 0 to the last element here. And what we're going to do is now just try something. So in order to see if it's a spare, well, we have to basically see if they the 2 pin numbers for each frame. So we're going to be looping through each frame now, right? That's the point of this for loop here. So we're looping through the vector, which will correspond to 1 struct, which will correspond to 1 frame, which will correspond to 2 pins, 2 pin numbers. So let's go ahead and make a total pins here, where we're going to just first use our vector here, and we're going to access the frame or the element. So we're going to access it like I, just like our array. And so we're at element I here. At element I, we are going to grab pins 1, and then we're going to add this to the same element here, right? The same element with the other one, pins 2. So bowl number 1 pins knocked, and bowl number 2 pins knocked, added together, and that will get assigned to total pins. And then we can check that to see if we have a spare. But first things, we don't want to check if we want a spare, we want to check to see if we have a strike. So we're going to use an if statement here to see if we have indeed got a strike. So in order for us to see if we've got a strike, well, how do you get a strike? Well, you kind of have to hit all 10 pins on the first bowl. So looking here, we can see that frame 1 and frame 10, they have 10 on the first frame. So if they hit 10 on the first frame, well, that means they can't hit 10 on the second frame. At least the way we have our thing set up, only with 10 frames. So if we want to see if it's a strike, we have to see if our first bowl, our pins number 1, is equal to 10. So if we access it through our vector here, and we're at this frame, we can say, okay, at this frame, right, whatever frame of this vector is pins 1, the first bowl, the first try of frame of this frame, is it 10? Did we get a strike? If we did get a strike, well, now we've added that other enum type, right, with those 4 different states here, we've added that to our struct here. So now let's go ahead and set this guy. So at this same frame, right, all of this we're dealing with one frame at a time. So we're going through the vector one element at a time and dealing with it one element at a time. So now we have this pin st variable. So now we're going to set this guy to a certain state. And in order to do this, we're going to assign it like this. Use the type of the enum. So we have pin status here. And basically we're going to use these double colons to access this enum type here. And we're going to set this guy to the strike state. So this means we have gotten a strike this frame. So we got a strike this frame. Yay. And so now we have successfully used our vector in a couple ways. We've used it to calculate this thing by accessing the pins from the same frame, the different pins from the same frame. And we've also created a condition here to check if at the same frame did pins 1 equal 10. If it does, we're going to set the same frame of our state here to pin status of strike. We've got a strike. And so now what we can do with this is we can set up even a switch statement with using this enum. So now that we have this state we can use from our vector at this same frame, right? We're all doing this at the same frame, the same element here. So now we can go ahead and switch this case this guy, and we can make a case of, remember we got to start with the type of our type of strike here. I spelled this wrong, that's right. Whoa. So now we have a type for, so now we're going to pass in our type of this frame and see what state it's at. Is it the strike state? Is it the spare state? Is it etc.? For now we've just done the strike state, but essentially we can do this. And so when we pass this guy through our switch, if we are at the strike state, we'll go through this case here. Let's go ahead and create a default state. And so also what we want to do in the strike state is, well, let's go ahead and print something. Okay, so we printed that. And now also we have this strike variable up here, this bool. Well, let's set this guy to true. We've gotten a strike. So let's say now we have our strike set up. Let's say we want to kind of output maybe a silly little statement if we have either gotten 0 strikes, none at all, or at least 1 strike. So 0 strikes or at least 1. So since we have this Boolean variable, we can do exactly that, right? So if we set it to false first, and we loop through our whole vector, right? We have to loop through our whole vector. We have to go through each element to see if we've gotten a strike. If we've never gotten a strike, we will never set strike to true, so strike will stay false. So if strike is false, then we're going to go ahead and print something out. Else, so if strike is anything but, oops, what the fuck? What happened? I don't know what happened there. Okay. So if strike ever does turn true, we get one strike and we go through this status and our status is a strike. We will set strike to true, so then that means we have gotten a strike. And so here are the two things we're going to print if we either do not get a strike at all, or if we get at least one strike. Wow, you got a strike, or no strikes, you are awful at bowling. Sad face. Alright, I'm going to go ahead and fill out some more information and go through. So I've gone through and added some more, and we'll just go through this. So we have completed this one ourselves. We check to see if we got a strike. Well, not to see if we gotten a spare, we're going to check if our total pins, so equals 10, right? So to get a spare, you have to get some pins in the first, and then the rest of the pins in the second. So they have to basically add up to 10, because if it's not a strike, right, we've already accounted for a strike, well then it's got to be a spare if it has 10 pins. So now that we've hit 10 pins, well now we're going to access at whatever element we're at whatever frame we're at. We're going to access that state, that pin state, and then we're going to set our pin state to our pin status here of spare. So this will say, okay, at this frame our status is a spare. And now here, if we've got at least one pin but not a spare, well, then that means we've gotten at least 0, right? So we've gotten at least 0 because we've already accounted for a strike when we've accounted for 10 of spare, so it'll be 0 through 9. And we're going to go ahead and again access our vector here at that element at that frame, set our pin state of that frame to our pin status here of none, which will do nothing, at least you hit something. And then lastly, we must have got 0 pins then, if there's none of these other cases. So we're going to access our vector here, again, access that element, that frame, and then access that pin state of that frame, and set that pin status to double gutter. So now we've accounted for 4 different cases and 4 different statuses of this bowling frame. All within our structs, which are being pointed to by a vector, which we are accessing each element of the vector again inside of this whole array. We're going through each one of them and doing this to every single frame. And then inside of our switch case here, I've added a couple more cases, so we have our strike. So we will see out, wow, strike, amazing, and set strike to true. That is our special case. And then we can also have our pin status of spare, or our pin status of none, or our default for double gutter, which will say nothing. But I'm just showing you we can use these enum types to set. We have 4 different states, and we can use these for stuff like this. So we can pass in the state and then check what kind of state. Well, we got a strike state, a spare state, none state, or the default state. And then we have gone ahead and checked, okay, if we do not get a strike at all, well, how do we check if we have not got a strike at all? Well, we have to loop through every single element. So we have to check all the elements. Only then, once we checked all the elements, if strike is false, we have to have not gone through and if strike remains false after going through the vector, we must have not got a strike, so we're going to be alpha and boolean. Elsewise, if strike does become true, that means we have become our state had to be a strike for us to set strike to true. And then we will know that, and that we've gotten at least once, and set that. And since that's true, well, we're going to go through here. I believe this is the majority of the program I wanted to go through. I know I covered a lot, but I hope I used a whole bunch of different things, a variety of things, and cool different things. I don't know, a lot of things. Let's see, what did we cover? We covered what? Arrays, 2D arrays, enum, structs, an enum inside of a struct, passing a vector of pointers by reference, creating, or even using a vector of pointers, and no, dynamically allocated. Well, I've done a whole lot. Oh, one last thing. We have dynamically allocated. So since we have dynamically allocated, we have been using this vector here, and we've been dynamically allocating to this vector. Well, we're going to have to handle that information and go ahead and delete our information somehow. So remember, we're dealing with a vector. In C++, there is a special thing where if you have an array that is dynamically allocated, if you don't know how to do that, check out some other video or another one of mine, I think. But you can delete just like that, and that can delete the array just fine. But for us to delete the structs from the vectors, we're going to have to basically go through this whole vector. So what I'm going to use is a special thing called the range-based for loop, and I'm going to use the type of auto, and let's just name this maybe DAM, dynamically allocated memory, yeah. Just so DAM for dynamically allocated memory. So we're going to loop through that through our bool struct pointer, right? So this is our vector. So dam is going to be an element from our vector, and we're going to loop through our whole vector in this range-based for loops. This is just how it works. We don't have to increment, it does it automatically. And what we can actually do is just go ahead and delete our dam here. So what we do by auto is it just sets it to kind of the auto, it figures out what type it needs. And then dam is going to basically going to be set to each element of the vector here. So we have our vector of information. So our dam is going to go through each of those through the whole array, or through the whole vector, sorry. It'll go through the whole vector, and as we go through, we're going to delete each one of those. And now we have successfully handled our memory and handled it safely, and hopefully we're not going to have any memory leaks. So this should definitely be the last thing. We covered a lot now. We covered quite a lot. I hope this was somewhat I hope you were somewhat able to follow through this whole video. I hope that this isn't that long, but thank you so much for watching. Again, if you like these, make sure to subscribe, maybe give it a like. And thanks so much for watching. See you later.